particular stage, what I think we'll do is we'll start constructing our scene, and the first thing we need to do that is to set up the space warps which are going to be used within our system. Now this thing is going to take a little bit of time, so obviously bear with us while we're actually building this. We've got to set up a fair amount of space warps which are going to affect not only the dust and debris that's going to be kicked up by this tornado, but also controlling the particles which are going to drive the animation of this barn destruction. So first thing we need to do is we need to set up a number of Vortex Space Warps which are all going to be linked to this tornado controller, and then set up their boundaries so that they are only affecting the particles on this guy within a certain radius. We'll set up wind space warps as well to get them to fly around in more kind of a natural pattern, so they're not just swirling around, they are kind of going like this as they're kind of moving around. And also we'll set up a Deflector space warp as well, which is going to encompass the scene to make sure that they don't intersect with the ground, or when they actually hit the deck they don't kind of pass through all the way through the surface. When the particles that are used to control this geometry are positioned, they are actually using the pivot points of the individual pieces of geometry. Now what that will basically entail is that because the scripts that we're going to be using to animate the actual geometry itself that references the particles, because the particles are actually going to be located in the center of each piece of geometry, the collision testing is only going to be referenced within the center of the piece of geometry. So you will get, like I said previously, you will get some geometry intersection, especially on these long pieces, slat geometry. So obviously bear that in mind. But like I said previously, we are going to scatter additional particles over the baked animation, which we'll obviously bake in later on, and when they hit the deflector, then also we'll have some debris kick up, so therefore when the slat hits the ground, it'll actually look kind of convincing, look kind of realistic, quite simply because as it gets into the ground and gets dragged across, we'll obviously have some kind of dust and debris being kicked up as well, so it'll actually work to our favor. Okay, so the first thing we need to do is let's start by going into the top viewport, and I'm just going to zoom back. Now you'll notice that the viewport update speeds are quite low, quite simply because of the sheer amount of geometry that we've actually got in here. So again, if you are having some redraw issues, try turning on this guy down here, which is the degradation override. So that will speed things up at the expense of the viewport not redrawing every single piece of geometry. Now you can obviously control this guy by right clicking on it and changing some of these properties to see what stuff gets redrawn and how it actually redraws when it's trying to keep the frame rate. So when it's trying to keep that for 10 frames per second value. Okay, so what I'm going to do first is I'm just going to scoot all the way back here, and I'm going to create a deflector, this guy here, and just stick that all the way across there. So what we've got is quite a large guy which is going to capture all the particles in the scene, so therefore they don't pass through this ground plane. Obviously this guy is considerably bigger, we don't need it that big, so I'm just going to go through now. Now we obviously need to set some of the properties in here, otherwise our particles are simply just going to bounce continuously once they've hit the deck. So obviously we don't want that, we don't want them to act like ping pong balls or like that, so therefore we need to set some additional properties in here. So therefore let's set the bounce, let's drop that down to 0.5, and we'll have a fair amount of variation in there. Going to crank that up to 25%. Now even though we've got a bit of variation going on in here, we want to add in a little bit of additional chaos in there, so we're not going to have that too high. We can set that up to about I set up to about 0.25%, so not that much. However, we actually want to increase the amount of friction, so as soon as it hits the deck it kind of almost stops. This is going to interact nicely with the forces which are going to be applied within the tornado, so as soon as a particle hits the deck, it's going to go kind of like this and slow down to almost a standstill, and once it actually stops, particles are going to be passed to another event to say, okay, we're not moving anymore, so we're not going to calculate until we actually get picked up again. So this friction, I actually want to set that up to a value of 40. Okay, so that's our deflector setup, which is going to affect pretty much everything within the scene. Now, what you could do at a later date is set up deflector properties for each individual piece. Like, for example, when a slat hits the deck, it might go off at a more obtuse angle. So if it comes down like that, it might actually bounce upwards or backwards, depending on how it actually hits the deck. Okay, so that's our deflector setup. So the next thing we need to introduce is a number of spacewalks which are going to be linked to this guy here. And like I say, this is going to be pretty long-winded, so bear with us while we set that up. Okay, so the first vortex I want to set up is one for the posts. So we'll actually start by working inwards and then outwards with regards to force strength. Now, I think what we'll do first is I'm just going to go to the bottom viewport and just position it in the center of our funnel there. Okay, and then go back to the top viewport so we can check that it's directly in the center. If I just go back to these 4 viewports, you'll notice that the direction is actually pointing straight downwards. Reason being is because we created it in the top viewport. By default, it actually points the arrow straight down. So what I want to do is obviously rotate this guy 180 degrees. So I'm just going to rotate that around like that. Make sure I've got angle snap on, does tend to help. And then swing that around 180 degrees so it's pointing straight up. Okay, now you'll notice that by doing that, obviously the direction is traveling in counterclockwise direction as opposed to clockwise, which it was previously when it was obviously swung back round. Now this is actually the right direction we actually want this thing to travel in, so that works for us. Okay, so with this positioned and orientated, what I want to do is link this guy to the tornado controller. So when this is scrubbed through, you can see this guy linked to our tornado controller. So let's go through and set up some of the properties in here. Now what we want to do is actually set this time on value to one that's obviously in a negative frame value. Reason being because, like I said previously, we obviously need to have the particles established before we obviously join us. So obviously this spacewalk needs to affect the particles prior to frame 0. So what I'm going to do is set the time on to -100, and I'm actually going to set the time off to 1000, just in case you decide to extend the length of this animation past frame 200. The values in the vortex shape group I'm actually going to leave as is. However, I'm going to take off this unlimited range because obviously we want the particles to be affected within a certain radius. We don't want them affected all the way through to infinity. So let's go through and start setting some of these guys. So what I want to do is I actually want to kill the actual drop. Reason being is because this guy is mainly just to do with the rotation. So because I've killed these values here don't need to be affected. However, I want to kill this dampening just for safety. Alright, the orbital speed I'm actually just going to increase a touch to about 0.55, and now this is when we start dealing with distances from the axis. So the actual range itself I want to set to 50 with a fall off of 100. Okay, so if I just quickly, just to illustrate, I'm just going to drop in a cylinder in here with a radius so you can actually see exactly how much influence we're going to have. So that's the value of 50 that we're going to be dealing with at full strength, and then the radius of 100. So the vortex needs to get this close to the posts. There we go, just pull that out again. Needs to get this close to the posts before the particles and therefore the geometry is actually picked up. So obviously bear that in mind. So the next one we're going to be doing is going to be out here, and then the one after that is going to be out here, so to speak. So the lighter objects, i.e. the slats and the tiles, are obviously going to be picked up with a vortex that's applied with a larger radius. So therefore we're kind of simulating masses with this vortex setup and also additional space warps that we're going to introduce later on. Okay, so back in this guy, I'm just going to rename that. Let's call that Vortex Post, something I haven't done yet. Okay, so next thing I want to do is I want to go through and adjust this dampening value. I actually want to set that down to 2, and the radial pull, I'm going to drop that down to 0.2, so these guys can get flung out a fair amount, so they're not constantly being rotated and being pulled into the center. Because they're pretty heavy, they're going to get pulled across and then maybe not even do a full 360 turn. They maybe just get pulled across and then dumped out over here, kind of thing. Same deal with the radius. This one I actually just want to increase a little bit on the range, and the fall off I'm actually going to drop to 90, which obviously the speed kind of pulls it out like this, and then the radial pull is obviously reduced, so therefore it doesn't get caught and pulled straight in like this. It kind of starts it moving, and if it gets flung outwards outside of this fall off zone of 90, then obviously it's going to get flung out and then dumped. Okay, and then to match the value of 2, I'm going to drop that guy in there as well. Okay, so that's the Vortex Post one set up. Next one we want to basically do is the next size up, and that is basically the inner beams. So what we can do, because we've got this guy established already, I can simply clone it by doing a copy and then label this guy. Let's call that Vortex Inner Beams. And let's start setting up some of the properties in here. Now, same kind of principle as before. Obviously we don't need to deal with the axial drop and the dampening and what have you. We simply basically need to go through and start tweaking the ranges for the radial pull. So the orbital speed we can leave as is, the range here we can leave as is, the fall off as well, the dampening as well. The radial pull here exactly the same. So like I say, it's simply just a case of we need to adjust the range here. So I'm actually going to increase that up to 70, so it's slightly stronger at full strength around here. But the fall off I'm actually going to increase up to 100. Okay, so we're dealing with like a larger fall off area now, so therefore these guys will obviously get picked up before the posts, because obviously we've got dealing with a wider fall off boundary. Alright, so that's that one set up. Next thing we basically want to do is deal with the roof support. So same kind of principle as before. This one I'm going to actually, before I do that, I'm going to set this icon size to slightly larger. This obviously has no effect to the end result, it's just the display in the viewport, so we can actually select them if necessary later on. Okay, so this one I'm going to copy again. This one I'm actually going to set to Vortex Roof Supports. There we go. And this guy, what I think I'll do is I'm actually going to increase the range for the orbital speed this time. I'm actually going to increase that up to 80, and the fall off I'm going to increase a little bit up to 110. Okay, so we've got a little bit of a larger radius for the picking up the roof supports. Okay, dampening I'm going to leave as is. Radial pull again, same deal, leave as is. The range, however, again I'm going to increase that up to 80 as well, and the fall off I'm going to increase up to 120, so that because obviously these guys are considerably lighter than the other objects in the previous spacewalks that are going to be affected. Okay, same as before, I'm going to increase the size of this as well. So again, we can select it in the viewport. One last one to do for this guy, for the simulation for the breakup, and that is to deal with the tiles and the slats. So I'm just going to copy that and call that tiles and slats. Okay, Again, last thing I need to do, same principle as before, just go through this capture and motion group and set up some of the additional properties, and that is simply a case of extending the range here up to, let's say extend that up to 100 with a fall off of 150. So again, wider fall off range, so these guys are actually going to start moving a lot sooner before everything else. Leaving these guys, actually I think we'll set the dampening up a little bit so it kind of smooths it out a little bit more. Radial pull I think will actually increase up to, I think we'll increase up to about 0.3. So they are getting tucked in or pulled into the vortex more than the other guys, because obviously these guys are considerably lighter than anything else. The range here, to match this guy up here, I'm going to increase that up to 100, and the fall off for the radial pull, I'm actually going to crank that up to about 180. So these guys are getting pulled more into the core and therefore going to be swirling around a lot more than the other lot. Okay, same principle as before. I'm just going to increase the size of that so we can see this guy in the viewport easier. Okay, that's pretty much the majority of these guys set up. So the next thing I want to do is go through the same kind of principle and set up stuff for the actual dust system itself, which is going to be the main dust rotation and what we mentioned in our reference for the central core and the outer cores. So again, same kind of principle as before. What we're going to deal with is similar settings, similar rotational settings and what have you, but again, tweaking the boundary values. Okay, so let's go and set those guys up. So what I want to do is I'm just going to select this inner one here, which is the vortex post. Same kind of principle as before. I'm going to copy this one, and this one I'm actually going to call vortex dust. So that's going to affect the main dust throughout the entire system, and I'm just going to pull this in so it's quite small in the viewport. Okay, so let's start setting up some of the values in this capture and motion group here. So what we need to do is drop this orbital speed down for the main dust itself. So what I'm going to do is drop that down to a value of 0.1, but I'm actually going to increase the range up to 150. So like I said, this is going to be dealing with the actual main dust that's kind of swirling around in here. So as the debris is being pulled around, the orbital speed is obviously going to overlap with the debris itself, which is going to look quite cool. So the range I'm going to say increase to 150, and the fall off I'm actually going to take up to a value of 300. To make it kind of more irregular, I'm also going to drop this dampening down to 1 as well. Now the radial pull I'm actually going to leave at 0.2, however the range, again same as before, I'm actually going to increase that up to 150, and the fall off up to 300 as well. Again, same deal, and I leave the dampening on this guy as well. Alright, because we're obviously dealing with a large fall off, I think I'm going to increase this icon size quite considerably up to, well, up to about there actually, so we can see exactly what's going on in the viewport. Okay, so that's the dust one sorted. The next one we want to do is have a look at the middle core of the vortex. So what I'm going to do is copy this guy. So I'm going to set that to vortex middle core. Now, because I actually want to redesign the shape of this vortex, I'm actually going to amend this taper length. I'm actually going to increase that up to a value of 400. Now obviously I don't want to start messing around with these guys here, quite simply because obviously going to be the same kind of rotational values as the dust. So therefore all I want to do is adjust the fall off. So I want to drop that down to a value of 200, and pretty much that's about it, apart from obviously tweaking these guys in here as well. So same kind of principle, I'm going to drop this guy down to 200 as well. Okay, so one last thing to do, actually before I do that, I think I'll just tweak in the top viewport, drop this guy down to about there. Okay, and one last one to set up, and that's the vortex outer core. So I'm just going to copy this guy and rename it vortex outer core. Okay, and go through and change some of the properties again within this capture and motion one. So this time what I want to do is I actually want to amend the damping and also the fall off on the axial drop, even though we actually haven't got any values in the axial drop value here, quite simply because obviously the wind's going to lift this off the deck, so this does have an effect on it overall. So this fall off I'm actually going to drop down to 200, and I'm going to increase the damping up to 3, quite simply because obviously the outer stuff doesn't need to raise up as much as the rest of the other guys. So the orbital speed, again, same kind of principle as before. I'm going to leave that at 1. The range I'm actually going to drop down to 100, so that we've got more of like a it doesn't kind of, you know, full. It's not full strength out here. It's actually is full strength out here. So it, in here, sorry. So we're dealing with like a larger radius of strength distribution. Okay, the fall off I think I'm going to leave as is. The damping I'm going to increase to 2, so it's kind of smoothed out for this larger outer debris. And same kind of principle with the radial pull. I'm going to drop that down to 100, and I think I'll leave the damping as is for this guy. Okay.